Assalamualaikum, students and friends. Once again, we look into the meaning of maximum speed and acceleration as applied in short distance running events. How do we compute the acceleration and the average speed of a typical sprinter? Stick around, watch and learn. The problem is a typical male sprinter can maintain his maximum acceleration for 2.00 seconds, and his maximum speed is 10.0 meters per second. After he reaches this maximum speed, his acceleration becomes zero, and then he runs at constant speed. Assume that his acceleration is constant during the first 2.00 seconds of the race. We also assume that he starts from rest and that he runs in a straight line. Question letter A: how far has the sprinter run when he reaches his maximum speed? And question letter B: what is the magnitude of his average velocity for a race of this length? Number one, 50.0 meters. Number two, 100.0 meters. And number three, 200.0 meters. In a short distance race, like a 100-meter dash, a typical male sprinter, starting from rest, can attain his maximum speed of 10 meters or 10.0 meters per second. He can maintain his maximum acceleration for a period of 2.00 seconds. This means that after 2.00 seconds, he is already running at his top speed of 10.0 meters per second, maintaining this constant speed until he reaches the finish line. In part A, we are required to find the distance run by the sprinter in the first 2.00 seconds when he reaches his maximum speed of 10.0 meters per second. And in part B, our target variable is the average speed of the sprinter for a race of these distances. All right. We have number one, 50.0 meters, number two, 100.0 meters, and number three, 200.0 meters. This problem is an application of the concepts of kinematics, specifically rectilinear motion or straight line motion. So before we find the distance run by the sprinter while accelerating from rest, we first compute the maximum acceleration of the sprinter. Okay, so the formula for determining the acceleration, which is assumed to be a constant acceleration, is A equals quantity V minus V naught divided by the time t, where V is the final speed and V naught is the initial speed, right? And since it started from rest, all right, the initial speed V naught equals 0. Substituting the given quantities, we get acceleration A equals 10.0 meters per second, all right, and minus 0. That will be divided by 2.00 seconds. So we will get the value of the acceleration A equals 5.00 meter per second squared, right? Rounded to three significant figures. All right. So this value for the acceleration implies that the sprinter is able to increase his speed from 0 to 10.0 meters per second in just a short period of time, which is 2.00 seconds. All right. So he just accelerate uh, at 5.00 meters per second squared. Now, we can proceed in determining the distance covered by the sprinter in the first 2.00 seconds while accelerating constantly. All right, using the formula d equals 1 half the product of the acceleration and the square of the time t. Right? So since the initial speed is 0, we don't include, all right, uh, anymore here the initial speed because anyway it is 0. Right? So substituting the given quantities, we get the distance d equals 1 half times the computed acceleration, 5.00 meters per second squared, and then multiplied by the square of the time elapsed, which is 2.00 seconds, the square of which equals 4.00 seconds squared. So doing our math, we get the value of the distance covered by the sprinter while accelerating constantly during the first 2.00 seconds equal to 10.0 meters, also rounded to three significant figures. Now, just to show you that in determining the distance covered by the sprinter while accelerating, okay, we have two other equations or formulas, right? So the alternative, or one of the alternative formulas is given here. Distance can also be computed by dividing the square of the final speed, or v squared, okay, over twice the acceleration. This is the formula to use if you're given the final speed and you already know the acceleration without using the given time elapsed, right? So substituting, we get distance d is equal to 10.0 meters per second, square that, and then divide it by 2 times the computed acceleration, 5.00 meter per second squared. So again, doing our math, we get the same answer for the distance d equals 10.0 meters. All right? And the second alternative formula is to divide the initial speed plus the final speed, then get their average. But since the initial speed is 0, so we just have here final speed divided by 2, right? And then that will be multiplied by the same time elapsed. This formula is based on the definition for average speed given to average or given to instantaneous speeds such as the initial and the final, okay, we can get the average by just dividing them by 2, then multiply by the time elapsed. All right? Now, this formula doesn't make use of the acceleration. All right? You don't need the acceleration as long as you know the final speed and that the initial speed is 0. Okay, you can use this formula. But uh, we are assuming here also that the acceleration of the body is also constant, right? In fact, for the 3 formulas that we are presenting here, the assumption is that the acceleration of the moving body is constant, right? So let's try this third formula. Let's substitute. The final speed is 10.0 meter per second divided by 2. That gives us 5.0 meter per second, and then multiplied by the time t, 2.00 seconds. Presto, we get the same result. The distance traveled during the first 2.00 seconds is indeed equal to 10.0 meters. In part B, we know that the average speed of a moving body can be determined by just dividing the total distance traveled, that's delta d, by the total time of travel, or delta t. So, based on this, we can determine first the time delta t that it would take the sprinter to finish the run, the remaining distance for a particular event. All right, delta d is the remaining distance divided by the maximum speed of the sprinter given in the problem, starting with the first event, which is the 50.0 meter dash. So this time delta t is just equal to 40.0 meters, and then divided by the given maximum speed that the sprinter has to maintain until he reaches the finish line. That is 10.0 meters per second. So we get the delta time, or delta t, equals 4.00 seconds. We can then determine the average speed of the sprinter, all right, for the first event, the 50.0 meter dash. So we just divide 50.0 meters by the total time, which is 6.00 seconds. We add 2.00 seconds to 4.00 seconds. That's how we got 6.00 seconds. So dividing these quantities, we get the average speed equal to 8.33 meters per second, rounded to 3 significant figures. If it were a 100.0 meter race instead, for the same maximum average acceleration and the same minimum speed of, or maximum speed of 10.0 meters per second attained in the same time interval 2.00 seconds, this sprinter would be running 90.0 meters at a constant top speed of 10.0 meters per second. All right, for a delta time, or delta t, equal to 9.00 seconds, also rounded to 3 significant figures. So his average speed, therefore, all right, for this particular race would be 100.0 meters divided by 11.00 seconds. Again, we add the first 2.00 seconds to 9.00 seconds. That's how we got 11.00 seconds. So his average speed for the 100.0 meter run or event, all right, is equal to 9.091 meter per second in 4 significant figures. And lastly, for the last event, the 200.0 meter run, right? So all other factors the same except for the distance traveled or the particular race, which is the 200.0 meter run. So the time interval delta t is 190.0 meter divided by 10.0 meter per second, right? And we will get the time interval delta t for this event equal to 19.0 seconds, also rounded to 3 significant figures. So moving on to finding the average speed of the sprinter for this event, we get the average speed equals 200.0 meters divided by the total time, 21.0 seconds, right? Again, we added the first 2.00 seconds to 19.0 seconds. That's how we got 21.0 seconds. So finally, doing our math, we find the average speed for the 200.0 meter dash. That is, the average speed equals 9.52 meters per second, also rounded to 3 significant figures. So that's it, we're done. Mabuhay, till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.